Hello everyone, I am Dr. Giri. Welcome to my research methodology channel. In this channel, we discuss research methodology and biostatistics in a way that is useful for undergraduates, postgraduates, and PhD scholars. In today's sessions, we discuss steps in research process which forms the foundation of research. In upcoming sessions, we discuss each steps individually. Stay tuned. Let us begin the journey together. To freshen up your memory, in the last session, we discussed wisdom hierarchy and philosophy, etymology and definitions of biostatistics, then what is methods and methodology, then aims and objectives of research. Now, coming into our important area, steps in research process. We can see that hourglass on the left side. Actually, the hourglass model in research is a conceptual framework that describes the structured flow of research process. It visually represents how research begins broadly and narrows down to specifics. You can see that it starts with the philosophical concept of problem finding and ends with the philosophical concepts of generalization, that is inductive inference. The upper end and lower end is broader. So let us see the structure of the hourglass model. The broad exploration, that is top of the hourglass, starts with general research area or problem, involves reviewing literature to understand existing knowledge, then leads to specific research question, that is hypothesis, then narrowing down to the middle of the hourglass, that is the study focuses on a specific methodology, defines research design, data collection and analysis. The research is conducted in a controlled and systematic manner. Then the lower portion, expanding results and application, that is the bottom of the hourglass. Research is documented, reported and shared. Results contribute to a new knowledge and suggest future research. Why this hourglass model is important? Because of the fact that it ensures structured and logical research approach, helps to maintain focus from broad ideas to a specific study execution, then ensures finding contribute back to the wider academic and practical field. So this model is widely used in scientific research, social sciences and evidence-based studies, ensuring a systematic flow from problem identification to application of results. Research problem is a specific issue, difficulty or a gap in the knowledge that a researcher seeks through their study. We will discuss the highlighted portions with an example. You have identified your area of interest as osteoarthritis of the elderly. You want to compare the Ayurvedic treatment modality with the conventional treatment modality for the patients with osteoarthritis for relieving their pain and improving their mobility. For this, you have to evaluate your problem, then you have to formulate the problem also. There is a format and criteria for evaluating and formulating the problem. In the next slide, we are going to discuss that. As said, we have already developed an area of interest with the formulation. We want to evaluate whether it is feasible, whether it is interesting to the community, whether it is novel. That means somebody has done the same thing, same research like that. Whether the concept that you have developed is ethical, then whether this is relevant to the community, scientific community, and whether it is relevant to that time period also. So that is very much important. For example, when COVID was there, if you are doing a research on osteoarthritis, it's not much relevant. And one more thing I want to give importance is that the problem finding, according to the situation, it changes. For example, for undergraduate students, your problem finding is to complete your study and to get the certificate. For PG scholars, for their thesis, the outcome is to improve the quality of the community, whatever research you are doing like that. But if the government is giving you a fund to do that research, the problem finding is a different concept. And in an emergency situation like COVID, and in that your problem is in front of you as COVID. So the problem finding according to the situation, it differs. But you have to be careful evaluating with finer criteria. Good question or good problem, but you may not be able to do that in your particular situation. That means it is not feasible. And as said, it should be interesting, it should be novel, it should be ethical, and it should be relevant to the community. So the findings have that scientific and social significance. Then formulating the research problem, the criteria is PICO criteria. PICO criteria is a framework used to formulate focused and researchable clinical questions, particularly in evidence-based medicine. So the PICO stands for P is for patient, I is for intervention, C is for comparison, and O is for outcome, and T sometimes it may not be possible to write in that question. Let us see the earlier example, how we can put in the PICO format. In elderly patients with osteoarthritis, does Ayurvedic therapy compared to conventional painkillers improve joint mobility and pain reduction over 6 months? The elderly patients with osteoarthritis is the P population, and does the Ayurvedic therapy, that is intervention, compared to conventional therapy, that is a comparison group, that improve the joint mobility and pain reduction, that is the outcome over 6 months of treatment, that is time period. The review of literature. The review of literature is a critical component of any research work, as it provides foundation for the study and situates the research within the broader scholarly context. The review of literature is a systematic examination and synthesis of existing research and publications related to a specific topic or research question. It defines gaps, trends, areas for further investigation. You should note that what is the main use of literature review? That is the familiarity of the subject, so that you can bring clarity and focus to the research problem and improve the research methodology. Next step is developing hypothesis. The conjunctural statement of the relationship between two or more variables is called hypothesis. There are working hypothesis, statistical hypothesis, and different type of hypotheses are there that we will discuss separately in the upcoming sessions. For the time being, we will see what hypothesis is. Hypothesis is a speculation or theory based on the insufficient evidence that tends itself to the further testing and experimentation. So after the research, the hypothesis may be proven true or false. But remember, in PhD thesis, that is why we are doing pilot work to find out whether it is that our working hypothesis is true or not. If it is true, then only we proceed for the PhD thesis. That is very important one. So it's a conceptual framework. It's tentative proposition, we can say that, and it enables you to conclude, because after doing the statistical work and everything, the hypothesis is important to conclude. Before going to next step, you should refresh your memory with evidence-based medicine, which we discussed in the last session. The link of the session is pinned in the comment box. The next step is research design. This is very important area. It's a blueprint, an arrangement or conditions in collections, plan, structure, strategy of navigation, so conceived as to obtain answers to research questions and problems. For our convenience, we divide the research design into study design, sampling design, and measurement design. First, we will see the study design. There are several types of classification, but today we discuss the classification published in Lancet. Basically, two types of studies, that is observational study and experimental study. If the researcher assigns exposure, then it becomes experimental study. There are two types of experimental studies, that is randomized control trial and non-randomized or quasi-experimental design. If randomization is done, then it is randomized control trial. Otherwise, it is non-randomized control trial or quasi-experimental design. Coming to the observational study, there are two groups of observational study, that is descriptive study and analytical study. If there is a comparative group, then it will become analytical study. Otherwise, it's descriptive study only. First of all, we will see what are the types of analytical studies. The three main types of analytical studies are cohort study, case control study, and cross-sectional study. Cohort study starts with exposure and ends with outcome. In case control study, it starts with outcome and ends with exposure. In cross-sectional study, the exposure and outcome are measured at the same time. The said three observational analytical trials are used to find out association between outcome and exposure and vice versa. We will discuss these three trials with an example each. First of all, the cohort study. The example is association between shift work and development of hypertension. In this, we select subjects, those who are doing the shift work and those who are not doing the shift work. So two groups, then following them for a particular period to find out whether they are developing the hypertension or not. Next is case control study. The example is to assess whether prior aspirin intake is associated with reduced risk of myocardial infarction. As it is a control study, we will take already established disease. So outcome is already established. Those who are having the myocardial infarction and those who have not had the myocardial infarction, and to find out whether they were taking aspirin as prior medication or prophylaxis. Next is cross-sectional study. Example is to examine relationship between salt intake and hypertension at a single point of time. Here we are assessing the exposure and outcome at the same time. So there is no temporality, so that we cannot measure the quantum of exposure. So that is why in hierarchy, the cross-sectional study comes just below the case control study. Now we will move to newer study designs. Newer study designs have evolved to address challenges in the traditional study designs. Newer study designs are useful to adapt challenges in healthcare and technology. So let us see some newer study designs. Adaptive clinical trials, umbrella trials, solidarity trial, pragmatic trial, and a list is given there. The adaptive clinical trial allows modifications to trial protocol based on interim results. The examples are Bayesian adaptive trials and seamless phase trials. It is used in drug development and speed up approval while ensuring safety. Umbrella trials evaluates multiple targeted therapies for a single disease with different genetic subtypes. It is common in oncology research. The Solidarity International Clinical Trial is to help find an effective treatment for COVID-19 launched by WHO. That will compare four treatment options against one standard care to assess relative effectiveness against COVID-19. It is done in multiple countries and or improve survival rates. Other drugs can be also added on the basis of emerging evidence. The pragmatic trials that we have already discussed in our earlier session. The basket trial tests a single across multiple disease sharing common generic mutations, helps in precision medicine. Then platform trial is there, Mendelian randomization trial studies are there, step-wedge cluster randomized trials are there, N of 1 trials. That is just like a case crossover design. It is not a case crossover design, but it is just like that. In that, a personalized trials where an individual serves as their own control. So used in precision medicine and chronic disease management. Another type is of digital and AI assisted trials. Now we will move on to sampling design. There are two types of sampling techniques, that is probability sampling and non-probability sampling. If we are giving equal chances of selection to each and every item of the population, then it is random sampling or probability sampling. Otherwise, it is non-probability sampling or non-random sampling. There are different methods of probability sampling and non-probability sampling. Some of the items are listed here. A detailed discussion on sampling technique will be made in the upcoming sessions. Simple random sampling, stratified random sampling, systematic random sampling, cluster sampling, and multi-stage sampling and multi-phase sampling. In the non-probability sampling, I have enlisted only 3, but there are several types of non-probability sampling. It is purposive sampling, convenience sampling, and quota sampling. We'll go to measurement design. Nominal, ordinal, interval ratio. There is an easy way of remembering this by a mnemonics NOIR, N-O-I-R. Nominal, ordinal, interval, and ratio. Nominal means name only, that is purely categoric. Then ordinal means it has got an order. For example, fair, good, excellent, like that. Next is interval. In interval, it is categorical, it is ordinal, at the same time, it has got a equal spacing. For example, 0 to 10, 10 to 20, 20 to 30. So in between, the space is equal, where in ordinal, you can see that between fair and good and excellent, the space we don't know whether it is equal or not. The ratio is a whole number with all these characteristics, and it has got a true zero also. So this is very much important while you are doing the statistical work. Next is data collection methods. So data can be divided into two according to measurability and according to collection procedure. According to collection procedure, it is divided into primary data and secondary data. If the data is collected by the researcher himself or the enumerators assigned by the researcher for a particular study, then it is primary data. If the data collected for one study and used for another study, then it is secondary data. According to measurability, the data is divided into two, that is categorical data and numerical data, or qualitative data and quantitative data. Here, you should remember that you should not mix the terminology of qualitative data with qualitative research, quantitative data with quantitative research. And we have already discussed in the earlier session. The categorical data may be of nominal or ordinal, and the numerical data or quantitative data may be of interval or ratio. Here, the quantitative data is of two types, that is discrete data and continuous data. For example, if you are calculating a grade, for example, 1 to 4 of any type of tumor grading, or 1 to 10 type of any type of grading, it has got a number, but the number is only repeated. So it is a discrete data. So in between 1 and 2, you cannot put 1.5 like that. So that is discrete data. Continuous data, example it, height, weight, etc. The height may be 30, 40, 30.2, 30.5 like that, just like the weight also. Now we will move to the data collection methods. What are the types of collection methods? The primary data can be collected by observation, interview, and questionnaire. This also we will discuss in the upcoming sessions. And the secondary sources, that is very much important. The examples are documents from the hospital records, census, earlier research, and government publication that can be used as secondary data. We are coming to the analysis of data. Here, in qualitative research, we will get the results in qualitative data only. There are different ways of analyzing it because we get the results in concepts, themes, or codes like that. In quantitative data analysis, we use statistical methods, and it is of descriptive statistics or descriptive methods, and inferential statistics or inferential methods we use. For descriptive statistics, we use tables, diagrams like that. And for inferential statistics, we use estimation, testing of hypothesis like that. In estimation, it can be point estimation, mean, proportion, interval estimation like that. Hypothesis testing, we will do the comparison between treatment, or we will make the association between exposure and outcome. To continue with, before we go for analysis, we should find out whether our continuous data following normality or not. For this, Sharperov-Wilk test and Kolmogorov-Smirnov test are used. After using this test, if your data is following normal, then you can go for parametric test. If it is following not normal, that it is a non-normal, then you should do non-parametric test. There are some advanced statistical methods to make a non-normal data to normal. After applying this, if the data is following, then you can go for parametric test. Otherwise, non-parametric test has to be adapted. The data we get may be univariate, bivariate, or multivariate for analysis. The univariate data may be categorical or quantitative. In categorical, we can analyze frequency, percentage, prevalence, incidence, like that. In quantitative analysis, we can do mean, median, mode, interquartile range, and standard deviation. For bivariate data, there are three options. It may be categorical versus categorical, or categorical versus quantitative, or quantitative versus quantitative. This we will discuss in the next slide. You want to analyze data with more than two variables, then you go for correlation and regression. Please go through the subheads, that is variable type, unrelated, and related. And in this, if it is categorical versus categorical, then we go for chi-square test or Fisher's extract. If it is unrelated, that is mutually exclusive. If it is related, that means before and after, we go for Magnemar test. And if it is unrelated, and if you are having more than two groups, then we go for the chi-square test and Fisher extract itself. Next is categorical versus quantitative. Here, if the data for comparing means, if it is unrelated, that is mutually exclusive, then we go for student t-test. If it is more than two groups, we go for one-way ANOVA. If it is related before and after, usually, then paired t-test is done. And if it is more than two groups, that is repeated ANOVA is done. Let us see with this an example. For student t-test, we want to compare Group A and Group B, that is, A has been given a medicine and B has been given a placebo. To compare the means, for example, hemoglobin, we go for student t-test. And if it is more than two groups, there are three groups, that is medicine A, medicine B, and medicine C. We want to compare the means of, example, hemoglobin level. What are the changes occurring in hemoglobin level? We go for one-way ANOVA. You are giving a medicine and before and after same subject you are testing, then you go for paired t-test. You are taking blood sample of a patient in every 21 days and you want to compare with another. So there are multiple measures that you are taking, repeated measures of the same patient. In that, we can do repeated measure ANOVA. Categorical versus quantitative, but it is not following normal. Then we have to go for non-parametric test. Same conditions. That is, if it is unrelated, we are having two groups, then we can go for Wilcoxon-Ransom test. And if it is more than two groups, we go for Kusker-Wallis test. If it is related, that is before and after, and it is not following normal, then we go for Wilcoxon sign rank test. If it is more than two groups, then we go for Fredman test. Next is quantitative versus quantitative. If it is unrelated, then we go for Pearson correlation coefficient. If it is related, then we go for Spearman rank correlation. Coming to the next step, the wider portion of the hourglass, that is a philosophical concept, generalization and interpretation. You can see that two images are there. One is sampling from a tangible population and another is creating an abstract population to fit an existing sample. Let us see what is sample and what is population. Population is a totality of elements of people with common character. The people or material which is having common characteristics is called population. The true representative of the population is called sample. These two images I will explain with an example. You want to find out a prevalence of a disease, prevalence of obesity, for example, in your place. So we have calculated there are 5,000 people are there. You are randomly collecting 300 samples from that population, then finding out how many people are having obesity out of 300. So you're applying that result to that population. So you're generalizing it into that population. Actually, you have taken the sample from the population itself. So that is the left side image shows. Next is an abstract population to fit an existing sample. In a randomized control trial, according to inclusion criteria, we are selecting, for example, the people with rheumatoid arthritis as per criteria of 2011 ACR EULA classification criteria for rheumatoid arthritis. Then we are randomly allocating into two groups. Here, the abstract population we imagine is that those who are having the rheumatoid arthritis in your area. After getting the result, we are generalizing this into that population. That is an abstract population. So these are very much important. The philosophical concepts of generalization and interpretation, or it is called inductive inference. From particular observations, broad inferences are drawn. This type of reasoning is called inductive inference. Before making the generalization or inductive inference, you have to pause and think. You should generalize according to the results that you obtain. So there are three ways of generalization, that is sample to population, that is statistical generalization that we are using in quantitative research, and another two types are analytic generalization and case-to-case transfer. These two are used mainly in qualitative research, and finding from a particular observation has been generalized to the results rather than the population. Next, we will come to the final step, that is preparation of the report. In this introduction, materials and methods, results and discussion, that is Imbrod method is usually used in all universities for dissertation and thesis. But some journals may prefer different type of reporting format. This is the general format for most of the universities for writing thesis and dissertation. Thank you for watching the video. If you have any queries, please feel free to email me. Don't forget to subscribe the channel and share it to others who might find it useful. In our next session, we will discuss research problem in detail. Stay tuned.